Okay, question 9. The graph can be used to convert between Celsius C and degrees F. So we've got the graph here, and it's asking us to find the values of M and K such that F equals MC plus K. Now, this is talking about a general straight line form of an equation. The plus C is where we cross, the plus K, sorry, in this case, is where we cross the axis here. So it's crossing at 32, so we can put that down easily enough. That's 32. What we've then got to do is work out what M is. Now M is the gradient, so what I'm going to do is take a point here and a point here, go across and then go up. So I've gone here 10 across and gone up. I've gone from 32 to 50. So if I divide 18 by 10, it's the difference in the y jump by the x jump. That'll give me what my M is, otherwise known as gradient, which is 1.8. So it's F equals 1.8 C, big C actually, plus 32. Question 10. We've got a probability question here. Probability it'll rain on Monday is 0.6. I'm just going to make this slightly smaller because there'll be a follow-up question on this. So the probability if it raining is 0.6. When it rains on Monday, the probability it'll rain on Tuesday is 0.8. So that immediately tells you that'll be 0.2 because each part adds up to 1. When it does not rain on Monday, so this way is 0.4. When it does not rain on Monday, the probability that it will rain on Tuesday is 0.5. So this is also 0.5. Now the question then says, part B, work out the probability that it will rain on both Monday and Tuesday. So probability of rain on Mon and Tuesday. Well, you're just going on the rain and then rain again. So it's as we walk along with times, so it's 0.6 times 0.8, which is 0.48. And then part C, work out the probability that it will rain on at least one of the 2 days. So you've basically then got the probability that it will rain on Monday and not on Tuesday, and also the probability that it won't rain on Monday and it will rain on Tuesday. So rains on Monday and not on Tuesday is 0.6 times 0.2, and the probability it doesn't rain and then rains is 0.4 times 0.5. Going this route. Times these two together you get 0.12, and then times this together you get 0.20. Add down in columns, you can get 0.32 as your answer at that point. Now that's saying it rains once. You also have to remember that it says at least one of the 2 days, so you can have it raining on both as well. So the probability then of 2R is 0.6 times 0.8, which we've actually done above, 0.48. So then we add these two together, and adding these two together then we then get our answer of 0.80, or just 0.8 probability of at least, and the swines with this putting at least in there, because I think you can tell, to be honest, I was looking just for once, but the at least thing means that you've got to look at the probability as well as it raining on 2 days. Question 11. We've got here the probability that's, sorry, not probability at all. The table shows some information about the weight of tomatoes produced on each tomato plant. On the histogram, on the grid, draw the histogram. So step 1 is we need to look at class widths, and then we've got frequency density. Now, they don't give much room at that part in the question, so you're going to have to fit this and squeeze this in. Class widths are the gaps in between the numbers at the top, and then we divide the frequency by the class width, so this divided by this, and that will then give us our frequency densities. The frequency densities are in then, so I'm going to use the scale in 5s, so it fits everything in nicely. The first one then goes up to 5, so I'm going to plot the points here. Then it goes from 5 to 10, that is, so it's going all the way across here. So I'll start drawing it out. So 5 to 10 up here, and then we're going across. Then from 10 to 12, we need to go all the way up to 7.5, and then to 12. So going across, each 2 counts as a single, so it will be 4 squares wide there. And that's 10 to 12. 12 then to 16, and that goes up to 6, so that's slightly less than the previous one. Then we've got 16 to 20, and 16 to 20 is 4. And then we've got 20 to 25, and that will be 2. So that's the histogram bit sorted. What we then need to do is we're asked to work out an estimate of the number of tomato plants that produce more than 15 kilograms of tomatoes. So what we've got to do there is estimate from 15 onwards. And it's quite straightforward in a sense, because we know the frequencies here is that's 16 and we know this is 10. So we just need to work out this frequency here. And the way we do it is we take our frequency density. Our frequency density is 6, and we then times that by our gap here, which is 1. So we've got 6 times 1, which is just the 6, so we know that's worth 6 in there. And then we add our 6, our 16, and our 10 together, which then gives us 32. And that's your answer.